for you tonight. And the set Z is the set of integers. Now let's just go ahead, just about what I mean by that is just this well-known set, -2, -1, 0. It's just the positive integers and their negative counterparts along with 0. Okay, so that's what we mean by Z. Okay, now we have this interesting question here for how many integers n is this expression, this quotient, also an integer. Now towards that, it turns out we need to do a synthetic or a long division. We actually have to divide. What we're looking for, folks, is a quotient and a remainder on this, and that's going to give us an approach on how to count these. We don't have to produce any solutions, we just have to count them. Okay, now if you'll take a look right here, there's a lot of missing terms here. Like for example, there's a x to the 5th term that's missing. Okay, that would be 0x to the 5th, x to the 4th is missing all the way. Not x, folks, I'm sorry, that's n. Okay, my bad. That should be, let me erase that. Okay, folks, let's see here. I'll get it together here. Okay, so notice here you have an n to the 5th term all the way to an n term missing. And so this 0 right here would correspond to n to the 5th. All right, and all the way down to n is missing, right? That explains these zeros. Now this process here where we're trying to obtain a quotient and a divisor is a lot easier than synthetic division. And I won't bore you with all the details. But basically, we bring this 1 down, which corresponds to the 1 coefficient of n to the 6 right there. Okay, then we just do a multiply and add. 4 times 1 is 4, add, you get 4. 4 times 4 is 16, add, you get 16, and so on. You see you get all these powers of 4. Now at the very end here, we get this remainder of 4109. Now what does that mean? That means our original expression is equal to all of this stuff that you see plus 4109 over the original divisor, which of course is n-4. Now what makes this problem relatively easy is that this entire piece right here is always going to evaluate to an integer. This part that I'm circling here, that would be the quotient, right? That would be the quotient. Y'all, you can see where I got these numbers, right? 4, 4, 16, 16, 64, all the way across. Okay, this is going to definitely evaluate to an integer, right? So all we really have to worry about is this very last term, the remainder over the divisor. Okay, so that's always going to evaluate to an integer, so we can kind of forget that. And right here, we just have to be aware that 4109, and this takes a little bit of time to determine this, but 4109 is actually equal to 7 times 587, okay? 4109 is 7 times 587. That's its prime factorization. Now, it takes a little bit of time to figure that out. It's not too hard to find it, actually, since if it's going to have a prime factorization, they'll have to either end in 7 or 1 and 9. So 7 times 7 is the 49 right here. Now, a little more depth on this, you could look at the square root of 4109, all right, and know where to start. Okay, 4109, and you can just try to find primes that are less than that, and I think that's somewhere around 64 or so. But anyway, it does take some time to determine that 7 times 5 is the prime factorization of 4109. But what I want to get across to you now is, and this is kind of cool how this works out, we know that n-4 must divide. Okay, so n-4 must divide 4109. Right? But if you'll notice, and let me put this in parentheses just to be precise, if n-4 divides 41 over 9, then this part will resolve to an integer also, right? But notice that that's the very same thing as saying n minus 4 would have to equal to, and I'm just going to put a plus or minus in front of this one time. You can have plus and minus divisors. You would have, in this set, you would have 4101, 7, 587, and 4109. Those are the only divisors, right? Those are the only possible divisors. Okay, but how many circumstances is that? Well, there's 4 in there, and then their negative counterparts. There's going to be 8 solutions. 8 solutions, which is the answer we're seeking. Only 8 times will that. There's only 8 integers where this will evaluate to an integer. Okay, where this piece right here will evaluate to an integer, which was the original question. So there's 8 solutions. That's the answer to the question. Now I'll just give you one concrete, but we're done right now. We're done. This is the answer to the question. There's 8 solutions or 8 integers that would take care of business here for us. Now just a concrete example. What if n minus 4, and again this is unnecessary, but just to give you a little bit of faith, if n minus 4 was equal to 587. Okay, if n minus 4 was equal to 587, okay, that would imply that n is equal to what, 591? And you can see that if you put 591 right here, you get 587 back, which would cancel with this factor right here to give you an integer value 7. But in any event, we've just counted them, and that is the answer. This is just a special case solution. Hope you enjoyed it.